Hi there, you're in the lab with your mate JJ. Today is Old Book Teardown Day. Today we're going to be tearing down an old book. My silly job title for today is Prime Hack. Today I'm the Prime Hack. And this is the book that we're going to be looking at. It's called Encyclopedia of Electronics Volume 3. This is obviously the third volume in the series. We've already done the first two, Volume 1 and Volume 2. So today we're going to keep on going and we're going to do Volume 3. There's seven volumes in the series and we're going to work our way through all of them. So let's jump over to the bench and have a look at what's in this book. All right, here we are on the bench. This is our book, our epic tome. This is Encyclopedia of Electronic Circuits Volume 3 by Rudolf F. Graf. It's fun, these books are by Graf and Sheets, so it's Graf Sheets. Very funny. There he is, there's a photo of the man himself. Alright, so this says, a giant collection of the latest, most widely used electronic circuits, an invaluable reference tool. Praise for the previous volumes. The American Reference Books Annual said, highly recommended for any library that serves people interested in electronics, from the hobbyist to the professional. And the Industrial and Process Control magazine said, a good quick reference guide for professionals who need fast answers to specific design problems. There you go. It goes on to say, the Encyclopedia of Electronic Circuits is back. Not a revision of the past two volumes, this third edition in the best-selling series offers you hundreds of all-new schematics for the latest electronic circuits from the leaders in the industry, such as Motorola, Teledyne, Texas Instruments, and many others. Easy to use, this giant collection of original circuits is tightly organized and includes a meticulous index and cross-references. You'll find more than 100 separate chapters, including complete descriptions of the latest available alarm and security circuits, smoke, moisture, and metal detectors, capacitance, current, voltage, and frequency meters, computer, fiber optic, and laser circuits, amplifiers, receivers, and transmitters, and much more. Locating a wide variety of circuits is virtually effortless in this incredibly convenient yet comprehensive sourcebook, the perfect reference guide for all levels of electronics practitioners. And here's a little blurb about the editor on the back here. Rudolf F. Graf holds a degree in communications engineering from the Polytechnic Institute of Brooklyn and an MBA from the New York University. That's interesting, he's an MBA. Look for these other references by Rudolf F. Graf. So there's the Electronic Data Book, 4th edition, okay. And then there's his previous two Encyclopedia of Electronics. So I don't know about the Electronic Data Book. Shall we have a look? Let's have a look to see if we can find out anything about the Electronic Data Book. Jump over to the computer. All right, so here we are on the computer. I put Electronic Data Book Rudolf Graf into Amazon Australia, and it turned up this Electronic Data Book, and then some other books also, I believe, from Rudolf F. Graf. Not sure about this one. Probably is him, but the initials aren't quite right. They're very expensive. This one's $60. That's not so bad. But these other ones, measuring circuits, it's paperback, 313 Aussie dollars. That's about 200 American dollars, I guess. So this also 250. That's just an insane price for a book. And I checked out other books by the author. So there's a couple there. This is volume 1 of the Encyclopedia, which we've already seen. So this is Exploring Light. And this is the book that got referred to. It's the 4th edition of the Electronic Data Book. And it doesn't have much to say for itself, but it says nomograms, tables, and charts supply information on international frequencies, the production and transmission of communication signals, passive and active components and circuits, mathematical formula and symbols, and the principles of physics. Wow. So anyway, this is the book. You can still get it. $61 you pay for that in Australia. Fair enough. Anyway, let's go and have a look at our encyclopedia. All right, we're back and we're ready to have a look what's in this guy. See if you can see that. I wonder what the zoom is like there. I'm just gonna stop for a minute and just check the zoom and the focus just to see that this looks okay for you. I'll be right back. Well, I can't seem to get it perfect, but this seems to be pretty good, so we'll just roll with what we've got here. This is the table of contents. We'll have a close look at that in a second. But first I wanted to see if there was any front matter. So this is dedicated to Cheryl Melissa, a budding scholar from Popsy. There we go. And the preface, Volume 3 of the Encyclopedia of Electronic Circuits adds about 1,000 new circuits to the ready-to-use files that were established by the publication of Volumes 1 and 2 of this set of circuit encyclopedias. These 3 volumes now offer an invaluable storehouse of about 3,000 carefully arranged and categorized, easy-to-access circuits. Volume 4 is scheduled for publication in 1992. Once again, it gives me great pleasure to extend my gratitude to William Sheets for his comments and contributions, and to Mrs. Stella Dillon for her virtuoso performance on the word processor. Wonderful. And then we're straight off and into it. So let's have a look at the contents. Basically, it's all categorized, and the chapters are the categories. So we've got active antennas, alarm and security circuits, amplifiers, analog to digital converters, annunciator, attenuator, audio amplifiers, automotive circuits, battery chargers, battery monitors, bridge circuits, burst generators, capacitance meters, carrier current circuits, clock circuits, comparators, compressor/expander circuits. Those are also called compander. It's a portmanteau of compressor and expander. We learnt that in an earlier edition of this book. Computer circuits, converters, counters, crystal oscillators, decoders, delay circuits, demodulator, detectors, digital to analog converters, display circuits, drive circuits, fiber optic circuits, field strength meters, filter circuits, flashes and blinkers, flow detector, fluid and moisture detectors, followers, frequency multipliers and dividers, frequency to voltage converter, function generators, gains, gas and smoke detectors, Hall effect circuits, high frequency amplifiers, humidity sensor, indicators, infrared circuits, instrumentation amplifiers, integrator circuits, intercom circuits, inverters, lamp control circuits, laser circuits, light controlled circuits, limiters, LVDT circuit, mathematical circuits, measuring and test circuits, medical electronic circuits, metronome, miscellaneous treasures, mixers, modulators, motor control circuits, multiplexers, noise reduction circuits, notch filters, operational amplifiers, optically coupled circuits, oscillators, oscilloscope circuits, phase detectors, photography related circuits, power amplifiers, fixed power supplies, high voltage power supplies, variable power supplies, power supply monitors, probes, programmable amplifiers, protection circuits, proximity sensors, pulse generators, ramp generators, receivers, rectifier circuits, resistance/continuity meters, RF amplifiers, sample and hold circuits, signal injectors, sine wave oscillators, sirens, warblers and wailers, solid state relay circuits, solenoid drivers, sound effects circuits, sound operated circuits, splitters, square wave generators, staircase generators, strobe circuit, switching circuits, tachometer circuits, tape recorder circuits, telephone related circuits, temperature controls, temperature sensors, temperature to time converters, Tesla coils, thermometer circuits, tilt meter, time delay circuits, timers, tone control circuits, touch switch circuits, tracking circuits, transducer amplifiers, transmitters, tremolo circuits, ultrasonics, video amplifiers, video circuits, voice circuits, voltage controlled oscillators, voltage converters, voltage to frequency converters, voltage meters / monitors / indicators, voltage references, and window detectors / comparators / discriminators. Then we've got sources on page 781, and the index begins on page 801. And we're off. So, this is chapter 1, active antennas. Okay, looks like we've got 2 active antenna circuits, both called the same thing. All right. Then we've got alarm and security circuits. We've got auto alarm, 1-chip burglar alarm, semiconductor fail-safe alarm, single IC auto alarm, and then 2 burglar alarms. This is the auto alarm. It's got a 555 timer in there and an LM3905. Apparently, according to that, U1 is a 3905 oscillator / timer. There you go. 1-chip burglar alarm. So we've got our 556 there, which is basically 2 555s in the same package. There you go. Semiconductor fail-safe alarm. False alarms produced by semiconductor failure are impossible with this burglar alarm circuit equipped with relays. Oh yeah. Single IC auto alarm. Again with the 556 package of timers. I assume they're using that just to generate the tone. Here's a burglar alarm again. It always just boils down to a bunch of switches for a burglar alarm, doesn't it? This uses the 555 timer as well. And this one also uses the 555 timer. So this circuit cannot be shut off for 10 to 60 seconds, even if the trip condition is immediately removed. It draws no standby power from the battery and is self-resetting. Yeah, right. Amplifiers. Gee, this is a long list of amplifiers. Input-output buffer amplifier for analog multiplexers. Absolute value Norton amplifier. Intrinsically safe protected op-amp. Plus or minus 15 volt chopper amplifier. Composite amplifier. Cascaded amplifier. Inverting amplifier. Non-inverting amplifier. Differential amplifier. Active clamp limiting amplifier. Wideband AGC amplifier. Polarity reversing low power amplifier, summing amplifier, AC coupled dynamic amplifier, forward current booster, DC stabilized fast amplifier, right amplifier, low noise photodiode amplifier, voltage follower amplifier for signal supply operation, current shunt amplifier, and constant bandwidth amplifier. Holy cow. This is the input-output buffer amplifier for analog multiplexers. There's an analog mux there. The precision input characteristics of the HA5147 help simplify system error budgets, while its speed and drive capabilities provide fast charging of the multiplexer's output capacitance. This speed eliminates an increased multiplexer acquisition time, which can be induced by more limited amplifiers. The HA5147 accurately transfers information to the next stage while effectively reducing any loading effects on the multiplexer's output. Absolute value Norton amplifier. Okay. The non-inverting amplifier has a gain of R2 on R3, which is 1 in this case, and produces a voltage of V out during a positive excursion of V in with respect to ground. The inverting amplifier accommodates the negative excursions of V in. Its gain is given by minus R6 divided by R7, which equals minus 1 to maintain symmetry with the non-inverting amplifier. R9 provides adjustment for the symmetry, supply variation, and offsets. Even though the circuit operates on a single supply, V in can go negative to the same extent that it goes positive. That's the LM390. Or is it the LM3900? I'm not sure. Intrinsically safe protected op amp. In intrinsically safe applications, it is sometimes necessary to separate sections of circuitry by resistors which limit current under fault conditions. The circuit shown provides an accurate analog output with effectively zero output impedance, despite having resistors in series with the output. The output voltage is given by V in times R2 divided by R1, which is independent of RA and RB. The values of RA and RB should be chosen to achieve the desired current limiting, but note that a proportion of the voltage given at the op-amp output will be dropped across these resistors. This limits the output swing at the load to approximately Vs times R load divided by Ra plus Rb plus R load, where Vs is the voltage swing at the op-amp output. Any type of op-amp would be suitable. Plus or 15 volt, plus or minus 15 volt chopper amplifier. This simple circuit is a gain of 1000 inverting amplifier. It will amplify sub-millivolt signals up to signal levels suitable for further processing. In almost all system applications, it is best to use as much gain as possible in the max 240, thus minimizing the effects of larger stage offsets. For example, if circuitry following the max 420 has an offset of 5 millivolts, the additional offset referred back to the max 420 input, gain equals 1000, would be 5 microvolts, doubling the system's offset error. Composite amplifier. Okay. A composite, I think the Americans say, what do they call it? Composite. We call it composite. Yeah. A composite configuration greatly reduces DC errors without compromising the high-speed, wideband characteristics of HA2539. The HA2540 could also be used, but with slightly lower speeds and bandwidth response. The HA2539 amplifies signals above 40 kHz, which are fed forward via C2. Okay. R2 and R5 set the voltage gain at minus 10. Where's R5? Up there. Alright. The slew rate of this circuit was measured at 350 volts per microsecond. Settling time to a 0.1% level for a 10 volt output step is under 150 nanoseconds, and the gain bandwidth product is 300 megahertz. The HA5170 amplifies signals below 40 kilohertz as set by C1 and R1, and controls the DC input characteristics such as offset voltage, drift, and bias currents of the composite amplifier. Therefore, it has an offset voltage of 100 microvolts, drift of 2 microvolts per degree Celsius, and bias currents in the 20 picoamp range. The offset voltage can be externally nulled by connecting a 20 kiloohm pot to pins 1 and 5 with the wiper tied to the negative supply. The DC gains of the HA5170 and HA2539 are cascaded. This means that the DC gain of the composite amplifier is well over 160 decibels. The excellent AC and DC performance of this composite amplifier is complemented by its low noise performance, 0.5 microvolt RMS from 0.1 Hz to 100 Hz. It is very useful in high-speed data acquisition systems. And we've got another amplifier. This is called a cascaded amplifier. Okay. Cascaded amplifier sections are used to extend bandwidth and increase gain. Using two HA2539 devices, this circuit is capable of 60 decibel gain at 20 megahertz. Got an inverting amplifier. Got a non-inverting amplifier. We've got a differential amplifier. This differential amplifier uses a CA3193 BiMOS op amp. This classical differential input to signal ended output converter, when used with low resistance signal source, will maintain level of CMRR if R1 equals R3 plus R4. I'll find out what CMRR means. Okay, so CMRR is the common mode resistance ratio, and what it means is that it can reject noise. There you go. Active clamp limiting amplifier. The modified inverting amplifier uses an active clamp to limit the output swing with precision. Allowance must be made for the VBE of the transistors. The swing is limited by the base emitter breakdown of the transistors. A simple circuit uses two back-to-back Zener diodes across the feedback resistor, but tends to give less precise limiting and cannot be easily controlled. Alright. Wideband AGC amplifier, built around an MC1496 integrated circuit of some description. The NE592, I'm not seeing that. Is that this? I'm not sure. Is connected in conjunction with a MC1496 balanced modulator to form an excellent automatic gain control system. The signal is fed to the input signal of the MC1496 and RC coupled to the NE592. Unbalancing the carrier input of the MC1496 causes the signal to pass through unattenuated. Rectifying and filtering one of the NE592 outputs produces a DC signal which is proportional to the AC signal amplitude. After filtering, this control signal is applied to the MC1496, causing its gain to change. We've got polarity reversing low power amplifier. That's interesting. We've got a summing amplifier. This circuit uses a CA3193 BiMOS op amp. Because input noise of the amplifier is increased by RF divided by R1 divided by R2, I'm not sure what that means. The gain that a single input will amplify is the gain of only one of the input channels. For good noise performance, use the smallest number of inputs. AC coupled dynamic amplifier. This circuit acts as a bandpass filter with gain and would be most useful for biomedical instrumentation. Low frequency cutoff is set at 10 Hz, while the high frequency breakpoint is given by the open loop roll-off characteristic of the HA5141 or 42 or 44. In this case, the AVCL equals 60 decibels, where the roll-off occurs at approximately 300 Hz. This corner frequency may be trimmed by inserting a capacitor in parallel with RF. Forward current booster. The LT1012 corrects DC errors in the booster stage and does not set high frequency signals. Fast signals are fed directly to the stage via Q5 and the 0.01 microfarad coupling capacitors. DC and low frequency signals drive the stage via the op-amp's output. The output stage consists of current sources Q1 and Q2 driving the Q3 to Q5 and Q4 to Q7 complementary emitter followers. The diode network at the output steers a drive away from the transistor bases when output current exceeds 250 milliamps, providing fast short circuit protection. The circuit's high frequency summing node is the junction of the 1K and 10K resistors at the LT1012. The 10K/39 picofarad pair filters high frequencies, permitting accurate DC summation via the LT1012's positive input. This current boosted amplifier has a slew rate in excess of 1000 volts per microsecond, a full power bandwidth of 7.5 megahertz, and a 3 decibel point of 14 megahertz. DC stabilized fast amplifier. This amplifier functions over a wide range of gains, typically 1 to 10. It combines the LT1010 and a fast discrete stage with the LT1008 based DC stabilizing loop. Q1 and Q2 form a differential stage which single ends into the LT1010. The circuit delivers 1 volt peak to peak into a typical 75 ohm video load. At A equals 2, the gain is within 0.5 decibels to 10 megahertz, with the minus 3 dB point occurring at 16 megahertz. At A equals 10, the gain is flat, plus or minus 0.5 decibels to 4 megahertz, with a minus 3 decibel point at 8 megahertz. The peaking adjustment should be optimized under loaded output conditions. This is a simple stage for fast applications where relatively low output swing is required. It is 1 volt peak to peak its 1 volt peak to peak output works nicely for video circuits. A possible problem is the relatively high bias current, typically 10 microamps. Additional swing is possible, but more circuitry is needed. We've got a right amplifier. The proliferation of industrial and computerized equipment containing programmable memory has increased the need for reliable recording media. The magnetic tape medium is presently one of the most widely used methods. This primary component of any magnetic recording mechanism is the right mechanism. The concept of the right generator is very basic. The digital input causes both a change in the output amplitude as well as a change in frequency. This type of operation is accomplished by altering the value of a resistor in the standard twin T oscillator. A H1201 analog switch was used to facilitate the switching action. The effect of the external components on the feedback network requires R6A and R6B to be much smaller than would normally have been expected when using the twin T feedback scheme. Alright, then we've got a low noise photodiode amplifier, a voltage follower amplifier for signal supply operation, current shunt amplifier, Constant bandwidth amplifier. Analog to digital converters. You've got a switch capacitor, ADC, a tracking ADC, ADC, and a half flash ADC. This is a switched capacitor ADC. The CMOS comparator in the successive approximation system determines each bit by examining the charge on a series of binary weighted capacitors. In the first phase of the conversion process, the analog input is sampled by closing switch SC and all ST switches, and by simultaneously charging all the capacitors to the input voltage. In the next phase of the conversion process, all ST and SC switches are opened, and the comparator begins identifying bits by identifying the charge on each capacitor relative to the reference voltage. In the switching sequence, all 8 capacitors are examined separately until all 8 bits are identified, and then the charge convert sequence is repeated. In the first step of the conversion phase, the comparator looks at the first capacitor, binary weight 128. One pole of the capacitor is switched to the reference voltage, and the equivalent poles of all the other capacitors on the ladder are switched to ground. If the voltage at the summing node is greater than the trip point of the comparator, approximately half the reference voltage, a bit is placed in the output register, and the 128 weight capacitor is switched to ground. If the voltage at the summing node is less than the trip point of the comparator, this 128 weight capacitor remains connected to the reference input through the remainder of the capacitor sampling bit counting process. And the process is repeated for the 64 weight capacitor, the 32 weight capacitor, and so forth down the line until all bits are tested. With each step of the capacitor sampling process, the initial charge is redistributed among the capacitors. The conversion process is successive approximation, but relies on charge shifting rather than a successive approximation register and reference DA to count and weigh the bits from MSB, most significant bit, to least significant bit. All right. Tracking ADC. The analog input is fed into the span resistor of a DAC. The analog input voltage range is selectable in the same way as the output voltage range of the DAC. We've got another ADC over here. This is made out of logic gates, inverters, and NAND gates. Conversion speed of this design is the sum of the delay through the comparator and the decoding gates. Reference voltages for each bit are developed from a precision register ladder network. Values of R and 2R are chosen so that the threshold is 1/2 of the least significant bit. This assures maximum accuracy of plus or minus half a bit. The individual strobe line and duality features of the NE521 greatly reduced the cost and complexity of the design. Got a half flash ADC. It's like mostly a block diagram there. Annunciator. Transformerless tone annunciator. This circuit does not require an output transformer or an output coupling capacitor. The annunciator can easily be turned on or off by a control point, control input voltage driving the 10 mega ohm input resistor R3. For a smaller acoustic output, replace output transistor Q1 with a 100 ohm resistor, while also raising the voice coil impedance to 100 ohms to prevent loading of the IC. Attenuators. Digitally programmable attenuator, programmable attenuator, and voltage controlled attenuator. This is the digitally programmable attenuator. We've got a programmable attenuator This circuit performs the function of dividing the input signal by a selected constant 1, 2, 4, 8, etc. While T, Z, or L sections could be used in the input attenuator, this is not necessary since the amplifier loading is negligible and a constant input impedance is maintained. The circuit is thus much simpler and more accurate than the usual method of constructing a constant impedance ladder and switching sections in and out with analog switches. Two identical circuits can be used to attenuate a balanced line. Voltage-controlled attenuator. This typical circuit uses an external op-amp for better performance and an exponential converter to get control characteristic of -6 decibels per volt. Trim networks are shown to null out distortion and DC shift and to fine trim the gain to 0 decibels with 0 volts of control voltage. Audio amplifiers. AGC with squelch control, gain control stereo amplifier, microphone amplifier, audio circuit bridge load drive, 20 decibel audio booster, micro size amplifier, audio amplifier, line operated amplifier, magnetic phono preamplifier, RIAA preamplifier, professional audio NAB tape playback preamplifier, mini stereo, speaker amplifier for handheld transceivers, TV audio amplifier. This is the AGC with squelch control. What does AGC stand for, do you reckon? Automatic gain control. Automatic gain control is a very useful feature in a number of audio amplifier circuits, tape recorders, telephone speakerphones, communication systems, and PA systems. This circuit consists of a HA5144 quad op amp and a FET transistor used as a voltage controlled resistor to implement an AGC circuit with squelch control. The squelch function helps eliminate noise in communication systems when no signal is present and allows remote hands-free operation of tape recorder systems. Amplifier A1 is placed in a inverting gain T configuration in order to provide a fairly wide gain range and a small signal level across the FET. The small signal level and the addition of resistors R5 and R6 help reduce nonlinearities and distortion. Amplifier A5 acts as a negative peak detector to keep track of signal amplitude. Amplifier A3 can be used to amplify this peak signal if the cutoff voltage of the FET is higher than desired. Amplifier A4 acts as a comparator in the squelch control section of the circuit. When the signal level falls below the voltage set by R10, the gate of the FET is pulled low, turning it off completely and reducing the gain to 2.4. The output A4 can also be used as a control signal. A4 can be used as a control signal in applications such as hands-free tape recorder system. Got gain controlled stereo amplifier, got a microphone amplifier, got audio circuit bridge load drive, got a 20 decibel audio booster, micro sized amplifier, audio amplifier, line operated amplifier. They mean power line. T1 isolates the unit from the line. Does it mean line or telephone line? And has a 24 volt center tap secondary. The output of the transformer is rectified by diodes D1 and D2 and filtered by capacitor R3 to provide 15 to 18 volts DC. The LM383 has built-in protection against speaker shorts. Magnetic phono preamplifier. RIAA preamplifier. The circuit essentially provides low frequency boost below 318 Hz and high frequency attenuation above 3150 Hz. Recent modifications to the response standard include a 31.5 Hz peak gain region to reduce DC-oriented distortion from external vibration. I think RIA is some standards body. I guess I'll go find out. Hang on. Okay, so RIAA refers to the Record Industry Association of America, and they did come up with this standardization for equalization of a signal. The idea is to boost the frequencies so that the low frequencies don't make grooves too big in the vinyl. So it's for vinyl records. Not terribly relevant today. Although I saw a record player at my friend's place on the weekend, so they're still around. All right, professional audio NAB tape playback preamplifier, mini stereo, speaker amplifier for handheld transceivers, TV audio amplifier, automotive circuits, automobile ignition substitute, courtesy light delay switch, lights on reminder, automobile locator, read head preamplifier, delayed extra brake light, digital tach/dwell meter, automobile air conditioner smart clutch, door ajar monitor, tachometer with set point, automobile voltage regulator, directional signals monitor, automatic headlight delay, backup beeper, electronic car horn, courtesy light extender, flashing third brake light, and headlight alarm. This is the automobile ignition substitute. The ignition substitute provides a constant power source for the ignition coil. Courtesy light delay switch, lights on reminder, automobile locator. This locator is made up of two parts. The first is an RF oscillator, whose circuit is shown in figure 8A84A. The second is a sensitive receiver, shown in figure 84B. The heart of the oscillator is a 555 timer IC. Tank circuit C2 and L1 is used to tune the transmitter. The antenna is coupled to the transmitter through C3. A telescopic antenna or a length of hookup wire will work quite well. At the receiver, the incoming signal is tuned by C5 and L2 before being passed on to the 741 IC. The 5 LEDs are used to indicate signal strength, and they light up in order 1 to 5 as the signal gets stronger. After the devices are built, the receiver and transmitter will need to be tuned. Tune the transmitter until the receiver's LEDs light. Separate the receiver and the transmitter. The farther apart they are, the better. And adjust R4 until you get a maximum strength reading only when the receiver's antenna is pointed directly at the transmitter. Place the transmitter on the dashboard and completely extend the antenna. To find your car, just extend the telescope antenna to its full length and hold it parallel to the ground. Point the antenna to your far left and then swing to the far right. Do that until you find in which direction the strongest signal lies, as indicated by the LEDs. The antenna will be pointing at your car. That's great. Read head preamplifier, delayed extra brake light, digital tach/dwell meter. It's a pretty complicated looking circuit. The heart of the circuit is IC2, a 4046 micro power phase lock loop. The incoming signals are fed to the phase lock loop after being buffered by IC1A and its associated components. The frequency of the incoming signal is multiplied by either 90, 60, or 45, depending on the setting of the cylinder select switch S2. That switch selects the proper output from counters IC3 and IC4, which are set to divide the output frequency of the phase lock loop by those amounts, and then send the divided output back to the comparator to the phase lock loop to keep it locked onto the input signal. Okay. The phase pulses output at pin 4 of IC2, then go through an AND gate, IC5D, which only passes the signal if the phase lock loop is locked onto an input signal, preventing stray readings, and then to the input of IC6. When in the TAC mode, the IC6 counts the number of pulses present at pin 12 during the timing interval generated by IC8 and the associated circuitry of IC1B. Because of the varied multiplication rate for the different cylinder selections, 90, 60, 45 for 4, 6, 8 cylinders respectively, the time interval is always constant at 1/3 of a second. The time interval is adjusted with R9, a 500 kilo ohm potentiometer. It is the only adjustment in the circuit. In the high TAC 1 to or times 100 range of 0 to 9,990 RPM, the output of IC2 is routed by switches S1A and S3 through IC7, a divide by 10 counter, which increases the count range tenfold. In the low TAC 2 or times 10 range of 999 RPM, the counter is bypassed. Automobile air conditioner, smart clutch, door ajar monitor, tachometer with set point, automobile voltage regulator, directional signals monitor, automatic headlight delay, backup beeper, electronic car horn, courtesy light extender, flashing third brake light, headlight alarm, battery chargers, PUT battery charger, lead acid battery charger, lead acid low battery detector, yeah, right. Universal battery charger, UJT battery charger, portable NiCad battery charger, universal battery charger, low battery warning. PUT battery charger. A short circuit proof battery charger will provide an average charging current of about 8 amps to a 12-volt lead acid storage battery. The charger circuit has an additional advantage. It will not function, nor will it be damaged by improperly connecting the battery to the circuit. With 115 volt at the input, the circuit commences to function when the battery is properly attached. The battery provides the current to charge the timing capacitor C1 used in the PUT relaxation oscillator. When C1 charges to the peak point voltage of the PUT fires, turning the SCR on, which in turn applies charging current to the battery. As the battery charges, the battery voltage increases slightly, which increases the peak point voltage of the PUT. This means that C1 has to charge to a slightly higher voltage to fire the PUT. The voltage on C1 increases until the Zener voltage of D1 is reached, which clamps the voltage on C1 and thus prevents the PUT oscillator from oscillating and charging ceases. The maximum battery voltage is set by the potentiometer R2, which sets the peak point firing voltage of the PUT. In the circuit shown, the charging voltage can be set from 10 volt to 14 volt, the lower limit being set by D1 and the upper limit by T1. Alright, but I don't know what PUT stands for. I'll see if I can find out. Okay, so a PUT is a programmable uni-junction transistor. It's this component here. There you go. Now we know. Lead acid battery charger. Lead acid low battery detector using an LM4250. The universal battery charger. And we've got a uni-junction transistor battery charger. This is a UJT. That's it there, I think. This circuit will not work unless the battery to be charged is connected with proper polarity. Very good. Portable Nikon battery charger. Universal battery charger. Low battery warning. Battery monitors. Quickly deactivating battery sensor. Automatic shutoff for battery powered projects. NiCad battery protection circuit. 9-volt battery life extender. Auto battery alternator monitor. Low battery detector. NiCad battery analyzer. Low battery protector. Low battery warning / disconnector. Battery capacitor tester. Battery splitter. Electric vehicle battery saver. Quickly deactivating battery sensor. Automatic shutter for battery powered projects. NiCad battery protection circuit. 9-volt battery life extender. Auto battery alternator monitor. Low battery detector. NiCad battery analyzer. Low battery protector. Low battery warning / disconnector. Battery capacity tester. Battery splitter. Electric vehicle battery saver. Bridge circuits. Auto zeroing scale. Accurate null / variable gain circuit. Remote sensor loop transmitter. Bridge transducer amplifier. Strain gauge signal conditioner with bridge excitation. Auto zeroing scale. Okay. Accurate null / variable gain circuit. Remote sensor loop transmitter. This circuit shows amplifier A1 as a sensor amplifier in a bridge configuration. Amplifiers A2 and A3 are configured as a voltage to frequency converter, and A4 is used as the transmitter. This entire sensor / transmitter can be powered directly from a 4 to 20 milliamp current loop. The bridge configuration produces a linear output with respect to the changes in resistance of the sensor. The voltage at the output of A1 causes the integrator output A2 to ramp down until it crosses the comparative threshold voltage of A3. A3 turns on Q1 and Q2. A1 causes the output of A2 to ramp up at a rate nearly equal to its negative slope, while Q2 provides hysteresis for the comparator. In addition, Q1 and Q2 help eliminate changes in power supply loop voltage. Amplifier A4 and Q3 are configured as a constant current sink, which turns on when the comparator current increases. The resulting increase in loop current transmits the frequency of the voltage / frequency converter back to the control circuitry. Bridge transducer amplifier. Strain gauge signal conditioner with bridge excitation. Burst generators. Portable RF burst generator and tone burst generator for European repeaters. portable RF burst generator, tone burst generator for European repeaters. Most European repeaters must be brought up with a 1750 Hz tone. The SK3733, also known as an ECG1197 integrated circuit, contains a crystal oscillator and is divided by -256, 1024, 2048, and 4096. A 7168 kilohertz crystal is used. Divide by 4096 output produces a 1750 hertz signal. Capacitance meters, 3.5 digits analog digital capacitance meter. Capacitance meter. Okay. Well, that's a bit of fun, isn't it? It's actually got a display. And here's another capacitance meter, and this one uses, looks like a meter. This one uses a 7-segment display. Carrier current circuits. Carrier current audio transmitter, carrier current FM receiver, carrier current AM receiver, and power line modem. Oh, that's cool. Carrier current audio transmitter. Carrier current FM receiver. Carrier current AM receiver. Power line modem. Clock circuits. Digital clock with alarm, oscillator/clock generator, single op-amp clock, wide frequency TTL clock. Digital clock with alarm, oscillator/clock generator, single op-amp clock, wide frequency TTL clock. Comparators. Window comparator, microvolt comparator with hysteresis, comparator/latch, frequency detecting comparator, precision comparator with balanced outputs and variable offset, dual limit microvolt comparator, window comparator, 4-channel comparator. Window comparator. A window detector is a specialized comparator circuit designed to detect the presence of a voltage between two prescribed limits, that is, within a voltage window. Microvolt comparator with hysteresis, comparator/latch, frequency detecting comparator, precision comparator with balanced inputs and variable offset, dual limit microvolt comparator, window comparator, 4-channel comparator. Compressor/expander circuits. A low voltage compander, hi-fi compressor with pre-emphasis, variable slope compressor/expander, and hi-fi expander with de-emphasis. Low voltage compander. This is what we were talking earlier about with the RIAA equalizer, I think. They scale the frequencies before transmission, and then they scale them back before playing them back. So that's why there's the two parts, the compression and the expansion. The compressor contains a high frequency pre-emphasis circuit which helps solve this problem. What problem? The NE575 is a dual gain control circuit designed for low voltage applications. The NE575 channel 1 is an expander, while channel 2 can be configured either for expander, compressor, or automatic level controller ALC applications. Matching de-emphasis on the expander is required. More complex designs could make the pre-emphasis variable. Variable slope compressor expander. Hi-fi expander with de-emphasis. Computer circuits. Automatic RS232 data selector. Interface to 680X, 650X, and 8080 families. RGB blue box. 5-volt powered EEPROM pulse generator. 1 of 8 channel transmission system. Microprocessor controlled analog signal attenuator. Multiple input detector. RS232 to CMOS line receiver. RS232C LED circuit. Spare flip-flop inverter. Coprocessor socket debugger. Oh wow. 20 MHz new bus. Clock phase lock. XOR gate up down converter. 8-digit microprocessor display. Logic line monitor. Long delay line for logic signals. This is the automatic RS232 data selector. With this data selector, only one RS232 port is used to connect two RS232 devices. For example, printer, plotter, etc. With a mini or micro computer. The operation is very simple. Power on will select FFI, which enables gates N1, N5, and N7. Now communication between computer and device B is possible. Detection of the switch command, i.e. control B character equals char2, selectable with wire wrap pins on the parallel outputs of the UART and IM6402 or equivalent, will set Q FFI equals high. Gates N2, N5, and N7 are open, so device A is connected with the computer until control B character is detected again. Transistor Q1 converts RS232 levels to TTL levels, while two LEDs indicate whether device A or B is linked. The baud rate generator provides the 16 times clock needed for the UART. Any baud rate ranging from 50 to 19,200 can be selected. Manual control of the selector is available with toggle switch S1. There you go. Interface to 680X, 650X, and 8080 families. Circuits to interface the SI7135 directly with two popular microprocessors are shown in figures 18.2a and b. The 8080/8048 and the MC6800 families with 8-bit words need to have polarity, overrange, and underrange multiplexed onto the digit 5 word. In each case, the microprocessor can instruct the ADC when to begin a measurement and when to hold this measurement. The SI7135 is designed to work from plus or minus 5-volt supplies. However, if a negative supply is not available, it can be generated using two capacitors and an inexpensive SI7660 or SI7661 IC as shown in figure 18.2c. RGB blue box. I learned a blue box was like used for free phone phreaking or something. The RGB blue box turns your PC's RGB monitor screen blue at the flip of a switch. That is, it makes your computer display bright white text on a blue background instead of the usual low intensity white on black. Oh, there you go. 5-volt powered EEPROM pulse generator. 1 of 8 channel transmission systems. Microprocessor controlled analog signal attenuator. Multiple input detector. RS232 to CMOS line receiver. RS232C LED circuit, spare flip-flop inverter, coprocessor socket debugger. The IBM PC debugger plugs into the PC's math coprocessor socket. The 8288 bus controller, IC1, regenerates control signals from the processor's status signals, S0, S1, and S2. Reset LED D1 lights if reset is active and holding the processor. Clock status LED D3 indicates that the processor is receiving a toggling clock signal. The address decode logic detects when the processor is doing a jump-on reset to the PC's BIOS ROM power on. Self-test then detects a fatal error and halts the processor. 20 MHz to new bus clock phase lock. XOR gate up/down counter. 8-digit microprocessor display. Long delay line for logic signals. Logic line monitor. This circuit requires only one CMOS IC, which is available in a 14-pin surface mount package. The figure shows the logic lines going to a standard 9-bit parity comparator chip. This device is conventionally used in data transmission and recording applications to provide a means of error detection by comparing the received 8 or 9-bit words with their corresponding parity bits. If the sum of ones in a received word is odd, but the odd parity bit is low, then that word is known to be in error and requires retransmission. When one of the logic lines decreases, the output of the parity comparator decreases, generating a wake-up interrupt to the microprocessor. The 9th line comes from a port on the microprocessor and is toggled to reset the output signal high again, ready for the next logic change. Converters. 10 Hz to 10 kHz V/F converter. Okay. Low frequency converter, positive to negative converter, buck boost converter, 4 to 18 megahertz converter, shortwave converter, isolated plus 15 volts DC to DC converter, voltage ratio to frequency converter, 50 megahertz thermal RMS to DC converter, pulse width to voltage converter, pulse width to voltage converter. These days we just call that pulse width modulation, I think. Step up/down DC-DC converter, square to sine wave converter, pulse height to width converter, pin photodiode to frequency converter, zero IB error V/I converter, regulated DC-DC converter, and pulse train to sinusoid converter. Okay, this is 10 Hz to 10 kHz V/F converter. Not sure what that means. This is a low frequency converter. Positive to negative converter. Buck boost converter. This converter can accommodate wide input voltage swings, such as the 8 to 15 volt swing typical of a 12 volt sealed lead acid battery. The low battery output indicates when input voltage drops below 8 volts. Pulling shutdown turns off the circuit. 4 to 18 megahertz converter, shortwave converter, isolated plus 15 volt DC-DC converter, voltage ratio to frequency converter, 50 megahertz thermal RMS to DC converter, pulse width to voltage converter, step up down DC-DC converter, square to sine wave converter, pulse height to width converter, pin photodiode to frequency converter, 0 IB error V/I converter. Single programming resistor RP provides an output current range of about 6 decades. Note that this resistor's TC is also a potential source of error. It dissipates 125 milliwatts when Vin equals 5 volts. The maximum deviation is typically 50 nanoamps or 0.0002% of full scale. This voltage-controlled current source uses optocoupler IC2 to eliminate an error found in more conventional circuits and which is caused by the output transistor's base current. Regulated DC-DC converter, pulse train to sinusoid converter, counters, low-cost frequency counter, up-down counter / extreme count freezer, 10 megahertz frequency counter, low power wide range programmable counter, 40 megahertz universal counter, frequency counter preamp, 1.2 gigahertz frequency counter. This is a low cost frequency counter. Up down counter extreme count freezer. 10 megahertz frequency counter. Low power wide range programmable counter. 40 megahertz universal counter. Frequency counter preamp. 1.2 gigahertz frequency counter. Crystal oscillators. Fundamental frequency crystal oscillator, easy startup crystal oscillator, crystal time base, low frequency Pierce oscillator, 1 megahertz Pierce oscillators, simple CMOS crystal oscillators, voltage controlled crystal oscillator, 2-gate quartz oscillator, crystal controlled reflection oscillator, temperature compensated crystal oscillator, 20 megahertz very high frequency crystal oscillator, marker generator, 100 megahertz VHF crystal oscillator, 50 megahertz VHF crystal oscillator. Fundamental frequency crystal oscillator, easy startup crystal oscillator, crystal time base, low frequency Pierce oscillator, 1 megahertz Pierce oscillators, simple CMOS crystal oscillator, voltage controlled crystal oscillator, 2-gate quartz oscillator, crystal controlled reflection oscillator, crystal controlled reflection oscillator continued, temperature compensated crystal oscillator, 20 megahertz VHF crystal oscillator, marker generator, 100 megahertz VHF crystal oscillator, 50 megahertz VHF crystal oscillator. Decoders. Second audio program adapter, tone decoder, encoder / decoder, direction detector / decoder, sound activated decoder. Second audio program adapter, tone decoder. That's cool. Adding a pair of one-shots to the output of a 567 tone decoder renders it less sensitive to out-of-band signals and noise. Without the one-shots, the 567 is prone to spurious output chatter. There you go. So it's a tone decoder integrated circuit. Fair enough. Encoder / decoder, direction detector decoder, sound activated decoder, delay circuits, leading edge delay, pulse delay with dual edge trigger, adjustable delay, leading edge delay, pulse delay with dual edge trigger, adjustable delay, demodulator, the 565 SCA demodulator. This application involves demodulation of a frequency modulated subcarrier of the main channel. Detectors. Wide range peak detector, Schmidt trigger, analog peak detector with digital hold, 500 Hz tone detector, audio decibel level detector with meter driver, precision envelope detector, frequency boundary detector, low drift peak detector, edge detector, null detector, precision threshold detector, out of bounds pulse width detector, digital frequency detector, missing pulse detector, digital peak detector, high bandwidth peak detector, wide bandwidth peak detector. We've got wide range peak detector, Schmidt trigger, analog peak detector with digital hold, 500 Hz tone detector, audio decibel level detector with meter driver, precision envelope detector, frequency boundary detector, low drift peak detector, edge detector, precision threshold detector, out of bounds pulse width detector, digital frequency detector, missing pulse detector, digital peak detector, high bandwidth peak detector, null detector. In this indicating comparator circuit, R2 sets the hysteresis. If the 741 saturates at the plus or minus 12 volts, the current in R1 will be approximately plus or minus 10 milliamps. If 0.1 voltage hysteresis is desired, then 0.1 volt per 10 divided by 10 milliamps equals 10 ohms for R2. All right. We've got a wide bandwidth peak detector, digital to analog converters. Digital to analog converters, 4-channel DA audio output amplifier, 12-bit binary 2's complement DA conversion system, 9-bit CMOS DA converter, multiplying DA converter, and positive peak detector. Okay, digital to analog converters, 4-channel digital to analog output amplifier, 12-bit binary 2's complement digital to analog conversion system, 9-bit CMOS digital to analog converter, multiplying digital to analog converter, positive peak detector. This peak detector uses a CA3100 BIMOS op amp as a wideband non-inverting amplifier to provide essentially constant gain for a wide range of input frequencies. The 1N914 clips the negative half of VN. Okay, a 500 microamp load current is constant for all load values, and the output reflects only positive input peaks. Display circuits, the 2-variable LED matrix display. There you go. Two-variable LED matrix display. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it looks like 8 by 8. Drive circuits. Practical current limiting coil driver, line synchronized driver, low power RS232C driver, totem pole driver with bootstrapping. Practical current limiting coil driver, line synchronized driver, low power RS232C driver, totem pole driver with bootstrapping. Fiber optics circuits. Fiber optic transmitter, digital fiber optic receiver, 50 megabits per second fiber optic LED driver, fiber optic link, low cost 100 M, not sure what that means. Low cost 100M board fiber optic receiver. 50 megabits per second fiber optic receiver. Fiber optic transmitter. Digital fiber optic receiver. 50 megabits per second fiber optic LED driver. Fiber optic link. Low cost 100M board. I think it means 100 million board fiber optic receiver. Yeah, 50 megahertz. 50 megabits per second fiber optic receiver. Field strength meters. We've got a sensitive field strength meter and a field strength meter. All right, so there's a sensitive field strength meter and then a field strength meter. Perhaps not so sensitive. Filter circuits. Programmable active filters, biquad audio filter, low power active filter with digitally selectable center frequency, glitch-free turbo circuit, voltage controlled filter, second order biquad bandpass filter, noisy signal filter, state variable active filter, scratch filter, dynamic noise filter, state variable filter with multiple filtering outputs, typical active bandpass filter, 6th order elliptic high pass filter, 4th order Chebyshev high pass filter. Sorry, I don't really know how to pronounce that, so I'll just muddle through. 4th order Chebyshev bandpass filter, rumble filter. Programmable active filters, biquad audio filter, low power active filter with digitally selectable center frequency, glitch-free turbo circuit, voltage controlled filter, second order biquad bandpass filter, noisy signals filter, state variable active filter, scratch filter, dynamic noise filter, state variable filter with multiple filtering outputs, typical active bandpass filter, 6th order elliptic high pass filter, 4th order Chebyshev high pass filter, 4th order Chebyshev bandpass filter, rumble filter. Doesn't have any description, the rumble filter. Flashes and blinkers. Ring around LED flasher, 3-year LED flasher, SCR ring counter, A-stable multivibrator, AC flasher, single lamp flasher, SCR chaser, SCR flasher, incandescent light flasher, 5-lamp neon flasher, alternating LED flasher, CMOS flasher, 60-watt flashing light, 2-state neon oscillator, alternating LED flasher, transistor flasher, minimum component flasher, and lamp flasher. Ring around LED flasher, 3-year LED flasher. I wonder what it means. Inserting two 1 meg resistors R1 and R2 in the output stage of one of the circuit's inverters limits the current needed by the oscillator to no more than a few microamps. This circuit includes a CD4007 package, which has 3 CMOS inverters. It forms a standard 3-inverter oscillator. Resistors R1 and R2 in series with separate drains on inverter pins 8 and 13 limit the oscillator's supply current. Capacitor C1 and resistors R5 set the off time of the oscillator. C1. Okay, R6 sets the on time. AVN10 km small power FET current limited by R4 drives two HLMP3300 LEDs. The LEDs consume about 20 milliamps for 1 millisecond. Their average current determines battery life. Since the LEDs in the circuit flash at 1 Hz, the average current drain is about 1/1000th of 20 milliamps, or about 20 microamps. A 9-volt battery should last about 3 years at the current drain, essentially the shelf life of an alkaline battery. There you go. So that's why it says 3 years. It'll flash for 3 years on one 9-volt battery. SCR ring counter. I actually thought it was going to say that it flashes every 3 years, but it flashes for 3 years. A-stable multivibrator, using an integrated circuit there. AC flasher, single lamp flasher, silicon-controlled rectifier chaser. Each lamp lights in succession to give the appearance of a growing column. SCR flasher. This DC flasher uses 2 SCRs and a unijunction oscillator clock to set the flash rate, which can be varied by changing the value of C1. Incandescent light flasher. 5-lamp neon flasher. Alternating LED flasher. CMOS flasher. 60-watt flashing light. Alternating LED flasher. 2-state neon oscillator. Transistor flasher. Minimum component flasher. Lamp flasher. Flow detector. Low flow rate thermal flow meter. Low flow rate thermal flow meter. Thermal flow. This design measures the differential temperature between two sensors. Fascinating. Fluid and moisture detectors. Fluid level control. Flood alarm or temperature monitor. Water level sensor and control. Dual liquid level detector. Soil moisture meter. Liquid level checker. Liquid level monitor. Fluid level control. Okay. Flood alarm or temperature monitor. Water level sensor and control. Dual liquid level detector. Soil moisture meter. Liquid level checker. Liquid level monitor. Followers. High frequency inverting follower. High frequency non-inverting follower. Simple follower. Voltage follower. This is the high frequency inverting follower, the high frequency non-inverting follower, a simple follower, and a voltage follower. Frequency multipliers and dividers. Pulse width multiplier, frequency doubler, digital frequency doubler, divide by 1.5 counter divider, odd number counter divider, single chip frequency doubler. Pulse width multiplier, frequency doubler, digital frequency doubler, divide by 1.5 circuit, odd number counter divider, single chip frequency doubler. Frequency to voltage converters. They didn't put the yeah. Okay. Frequency to voltage converter. Frequency to voltage. There you go. 6 components can configure a circuit whose output voltage is proportional to its input frequency. Function generators. Gee, there's a lot of these. Precision one-shot, linear triangle wave timer, 4-output waveform generator, function generator, classic op-amp A-stable multivibrator, programmable triangle/square wave generator, non-integer programmable pulse divider, XOR gate complementary signal generator, low cost FSK generator, harmonics generator, low frequency FM generators, positive triggered monostable, precision audio waveform generator, monostable multivibrator, versatile 2, I'm not sure what that is that phi? I'll have to look it up, hang on a sec. Alright, I'm back and I got myself a fresh coffee too. Yeah, so phi is some sort of angle. I don't get it completely, but I think it's an angle. Fixed frequency generator, single supply multivibrator, easily tuned sine/square wave oscillator, astable, just says astable. I don't know what it means. Usually it's an astable multivibrator, isn't it? 2 function signal generator, triangle generator, monostable operator, programmable frequency free running multivibrator, function generator, programmable frequency astable, linear ramp monostable, low frequency multivibrator, retriggerable one-shot, astable multivibrator, single control function generator, triangle/square wave generator, variable duty cycle timer, basic function generator, wide range tunable function generator, sawtooth and pulse generator, precise triangle/square wave generator, and wide range triangle/square wave generator. Okay, what did they call it again? Function generators. There's a lot of them. Precision one shot. Linear triangle wave timer. 4 output waveform generator. Function generator. Classic op-amp astable multivibrator. Programmable triangle/square wave generator. Non-integer programmable pulse divider. XOR gate complementary signal generator. Low cost frequency shift keying generator. Harmonics generator. Low frequency FM generators. Positive triggered monostable. Precision audio waveform generator. Monostable multivibrator. Versatile 2-phi pulse generator. Fixed frequency generator. Single supply multivibrator. Easily tuned sine wave square wave oscillator. Astable with a 555 timer. There you go. 2 function signal generator. Triangle generator. Monostable operation. Programmable frequency free running multivibrator. Function generator. Programmable frequency astable. Linear ramp monostable. Low frequency multivibrator. Retriggerable one shot. Astable multivibrator. Single control function generator. Triangle/square wave generator. Variable duty cycle timer. Basic function generator. Wide range tunable function generator. Sawtooth and pulse generator. Precise triangle/square wave generator. Wide range triangle/square wave generator. Games. We've got a coin flipper, who's first, and electronic dice. Alright. So there's your coin flipper. We've got who's first. Using 2 silicon controlled rectifiers, this control circuit is designed to lock out the other SCR when one has been triggered, so only one lamp will light. Okay, so it just checks who hits the button first. Electronic dice. Oh, that's cool. Look, it actually, yeah, okay. I like this electronic dice. That's fun. I might make a note of that circuit. Hang on a sec. Oh, I suppose we do it together. Got my notebook here. What's the date today? 10th of the 10th. That's good. So that's a good internationally compatible date. You don't know if I put the day first or the month first. So this is N. I'll do this in fast forward. All right, so I'm just making some notes about circuits that I am particularly interested in and might build. So I think we might build these electronic dice. That looks like fun. All right, on we go. Gas and smoke detectors. Smoke detector, furnace exhaust gas temperature monitor with low supply detection, methane concentration detector with linearized output, smoke gas vapor detector, gas/smoke detector, smoke detector, gas/smoke detector, and an SCR smoke alarm. I tell you what, I wouldn't be making my own smoke detectors. You get that wrong and something burns. Smoke detector, methane concentration detector with linearized output, gas smoke vapor detector, gas smoke detector, furnace exhaust gas temperature monitor with low supply detection, smoke detector, SCR smoke alarm, gas smoke detector, Hall effect circuits. Current monitor, security door ajar alarm, Hall effect switches, Hall effect compass. All right. Current monitor, security door ajar alarm, Hall effect switches, Hall effect compass. High frequency amplifiers. 2 to 30 megahertz, 140 watt PEP amateur radio linear amplifier. 80 watt PEP, 3 to 30 megahertz, 12.5 to 13.6 volt amplifier. 29 megahertz amplifier. 28 decibel non-inverting amplifier. Wideband ultra-high frequency amplifier with high performance FETs. Broadcast band RF amplifier. Miniature wideband amplifier. Wideband 500 kilohertz to 1 gigahertz hybrid amplifier. 2 to 30 megahertz, 140 watt PEP amateur radio limiter amplifier, linear amplifier. 80 watt PEP, 3 to 30 megahertz, 12.5 volts, 13.6 volt amplifier. I suppose I better look up what PEP stands for. I'll be back in a sec. All right, so PEP stands for peak envelope power. So it's a peak measurement, not an average measurement. .29 megahertz amplifier, 28 decibel non-inverting amplifier, wideband UHF amplifier with high performance FETs, broadcast band RF amplifier, miniature wideband amplifier, wideband 500 kilohertz to 1 gigahertz amplifier, hybrid amplifier, humidity sensor, a low cost humidity sensor. The sensor is an RC oscillator in which a water-absorbent plastic film is the insulator in the capacitive element. The capacitance of the film increases with the amount of water it absorbs from the air and thus reduces the oscillation frequency. A frequency counter produces a digital output that represents the change in frequency and hence the change in relative humidity. The sensor can be used to measure humidity in the atmosphere, in the soil, and in industrial gases, for example. A Schmidt trigger type IC is connected to the capacitor, which consists of a film of a commercially produced sulfonated fluorocarbon polymer, 2 inches, 5.08 centimeters square, sandwiched between perforated metal plates. The oscillation frequency decreases almost linear from about 100 to 16 kilohertz as the relative humidity increases from about 20 to 76%. Indicators: stereo indicator, on the air indicator, receiver signal alarm, RF actuated relay, visual level indicator. Stereo indicator, visual level indicator, receiver signal alarm, RF actuated relay, on the air indicator. Infrared circuits: infrared wireless speaker system, long-range object detector, IR receiver, IR transmitter, digital IR transmitter, simple IR detector, infrared transmitter, infrared transmitter. Infrared wireless speaker system. Oh, that's fun. Long-range object detector. Infrared receiver, IR transmitter, digital IR transmitter, simple IR detector, infrared transmitter, infrared transmitter. Instrumentation amplifiers: ultra precision instrumentation amplifier, strain gauge instrumentation amplifier, instrumentation amplifier, wideband instrumentation amplifier, biomedical instrumentation differential amplifier, differential instrumentation amplifier, thermocouple preamplifier, low power instrumentation amplifier. Ultra precision instrumentation amplifier, strain gauge instrumentation amplifier, instrumentation amplifier, wideband instrumentation amplifier. Has an input resistance of 1 mega ohm. Biomedical instrumentation differential amplifier, differential instrumentation amplifier. I'm just thinking about this still, that input resistance of 1 mega ohm. Just give me 1 second. All right, I'm back. So what I did was I just looked up input resistance, which is also called input impedance, and this is 1 mega ohm, which is high. And what I had trouble remembering was if you want a high input impedance or a low input impedance generally. And the answer is you want a high input impedance because it will consume less power. So, and similarly, you want a low output impedance. So you want low output impedance and high input impedance. And this is high input impedance for this amplifier. There you go. Biomedical instrumentation differential amplifier, differential instrumentation amplifier, thermocouple preamplifier, low power instrumentation amplifier. Integrator circuits: resettable integrator, integrator with programmable reset level. This is a resettable integrator and an integrator with programmable reset level. Intercom circuits. Personal pocket pager, bidirectional intercom system, intercom, hands-off intercom, two-way intercom. Personal pocket pager. Okay, cool. Bidirectional intercom system, intercom, hands-off intercom, two-way intercom. Inverters. 12 volt DC to 117 volt AC at 60 Hz power inverter, power MOSFET inverter, medium power inverter, complementary output variable frequency inverter, precision voltage inverter, and a power inverter. 12 volt DC to 117 volt AC at 60 Hz power inverter, power MOSFET inverter. There's a couple of MOSFETs in there. IRF 511. Medium power inverter, complementary output variable frequency inverter, precision voltage inverter, power inverter. Lamp control circuits. Halogen lamp dimmer, pseudo-random sequencer, light modulator, lamp life extender, phase control, triac light dimmer, 800 watt soft start dimmer, solid state light dissolver, line voltage operated automatic night light, 8 watt fluorescent lamp inverter, pulse width modulation lamp brightness controller, constant brightness control. Halogen lamp dimmer, pseudo-random sequencer, light modulator, lamp life extender, phase control, triac light dimmer, 800 watt soft start light dimmer, solid state light dissolver, phase control. Line voltage operated automatic night light, 8 watt fluorescent lamp inverter, pulse width modulation lamp brightness controller, constant brightness control. Laser circuits. Visible red continuous laser gun, laser diode pulses. Visible red continuous laser gun, laser diode pulses. The laser diode pulsar is a simple drive circuit capable of driving the laser diode with a 10 amp 20 nanosecond pulses. For a 0.1% duty cycle, the repetition rate will be 50 kHz. A complementary emitter follower is used as a driver. Switching speed is determined by the FT of the bipolar transistors used in the impedance of the drive source. A fast drive circuit is shown. It can supply higher peak gate current to switch the IRF 520 very quickly. This circuit uses a Morse power totem pole stage to drive the high power switch. The upper MOSFET is driven by a bootstrap circuit. Typical switching times for this circuit are about 10 nanoseconds for both turn on and turn off. Light controlled circuits. Flame monitor, low light level drop detector, light controlled lamp switch, optical sensor to TTL interface, light sensitive audio oscillator, light level detector, lighted display and brightness control, warning light and marker light, light controlled one-shot timer, solar triggered switch, sun tracker, photoelectric AC power switch. Flame monitor, low light level drop detector, light controlled lamp switch, optical sensor to TTL interface, Optical sensor to TTL interface continue. Okay, cool. That's not altogether dissimilar to what we made the other day. We made that photo, we used a photo interrupter. And it's an optical to TTL interface. Anyway, that was for Module Monday, last Monday. Light sensitive audio oscillator, light level detector, light display brightness control, warning light and marker light, light controlled one-shot timer, solar triggered switch, sun tracker, photoelectric AC power switch, limiters, noise limiter, dynamic noise reduction circuit, output limiter, noise limiter, dynamic noise reduction circuit, output limiter. It's a pretty simple looking circuit, isn't it? LVDT circuit, LVDT driver demodulator. A very simple motion transducer can be constructed using the circuit shown. The output is biased to 1/2 the supply voltage. This requires special interface circuitry for the signal readout. One simple method is to use a 0 centimeter in a bridge configuration. The displacement now can be measured as a positive or negative meter reading. Readout sensitivity is a function of the particular LVDT and of the gain of the error amplifier. DC offsets can be nulled by using a simple offset adjustment circuit as indicated. I was hoping they were going to tell us what LVDT stands for. Let me go look it up. So LVDT is a linear variable differential transformer. It's a type of transformer. It's got a primary and 2 secondaries. I'll put a link in the show notes. Mathematical circuits. Divide multiplier with only one trim, adder and subtractor. Divide multiplier with only one trim, adder, subtractor. Cool. I might make a note about the adder, because the cool thing about the adder is you should be able to couple them together and add more digits. So let's say page 327 adder. I'll have a look at that again someday. All right, measuring and test circuits. Duty cycle monitor, 3-in-1 test set, stereo power meter, wide range RF power meter, LED peak meter, LC checker, tachometer and direction of rotation circuit, very short pulse width measurer, QRP SWR bridge. Is that shortwave radio maybe? Not sure. Electrostatic detector, current monitor and alarm, pico ammeter circuit, paper sheet discriminator for printing and copying machines, precision frequency counter / tachometer, motor hour meter, stud finder, low power magnetic current sensor, line current monitor, S meter, hot wire anemometer, audible logic tester, SCR tester, digital frequency meter, low current measurement system, simple continuity tester, sound level meter, LED panel meter, optical pickup tachometer, peak decibel meter. All right. So, sorry, just trying to get comfortable in this chair here. We've got duty cycle monitor. It's pretty involved, isn't it? 3-in-1 test set. This circuit is designed around a 4049 hex inverter / buffer. 2 inverters are used in a dual frequency signal injector circuit. Another inverter is used as a logic probe, and the remaining 3 inverters are used as a sensitive dual input audio signal tracer. Stereo power meter, wide range RF power meter, Wide range RF power meter continued. Got an LED peak meter. LC checker. Tachometer and direction of rotation circuit. Very short pulse width measurer. QRP SWR bridge. Electrostatic detector. The heart of the electroscope is the two junction FETs, Q1 and Q2, connected in a balanced bridge circuit. Yeah, okay, cool. I'm going to actually make a note of this circuit. I'm going to come back to that one. So this is page 337. Electrostatic detector. All right. Current monitor and alarm. Picoammeter circuit. Paper sheet discriminator for printing and copying machines. Stud finder. There's a stud right here, baby. Precision frequency counter tachometer. Motor hour meter. Low power magnetic current sensor. Line current monitor. S meter. Hot wire anemometer. Audible logic tester. SCR tester. Digital frequency meter. Low current measurement system. Simple continuity tester. Sound level meter. LED panel meter. Optical pickup tachometer. Peak decibel meter. Medical electronics circuits. 3-chip EKG simulator. Breath monitor. Stimulus isolator. Constant current stimulator. 3-chip EKG simulator. Breath monitor. Stimulus isolator. Constant current simulator. Stimulator. Metronome. Downbeat emphasized electronic metronome. Downbeat emphasized electronic metronome. The musical wonks probably know what that means. Miscellaneous treasures. Closed loop tracer, pulse amplitude discriminator, tracer receiver, central image canceller, bug tracer, breath alert alcohol tester, automatic electronic music, positive input negative output charge pump, acid rain monitor, simple low cost RF switch, burst power control, flame igniter, barcode scanner, 50 megahertz trigger, air motion detector, bug detector, door opener. Closed loop tracer, pulse amplitude discriminator, tracer receiver, central image canceller, bug tracer, breath alert alcohol tester, electronic music, positive input negative output charge pump, acid rain monitor, simple low cost RF switch, burst power control, flame igniter, barcode scanner. Well, that's interesting, isn't it? Wow. 50 megahertz trigger, air motion detector, bug detector. This RF detector can locate low power transmitters, bugs, that are hidden from sight. It can sense the presence of a 1 milliwatt transmitter at 20 feet, which is sensitive enough to detect the tiniest bug. As you bring the RF detector closer to the bug, more and more segments of its LED bar graph display light, which aids in direction finding. The front end has a 2-stage wideband RF amplifier and a forward bias hot carrier diode for a detector. After detection, the signal is filtered and fed to IC1, an LM3915N bar graph driver having a logarithmic output. Each successive LED segment represents a 3 decibel step. Door opener. Mixers. Signal combiner, simple mixer, input buffered mixer, 4-channel mixer, universal mixer stage. Signal combiner, simple mixer, input buffered mixer, 4-channel mixer. Universal mixer stage. Modulators. RF modulator, SAW oscillator modulator, RF modulator, modulation monitor, pulse position modulator, pulse width modulator, balanced modulator, double sideband suppressed carrier modulator. RF modulator, SAW oscillator modulator, RF modulator, modulation monitor, pulse position modulator, pulse width modulator, built on the old 555, balanced modulator, double sideband suppressed carrier modulator, motor control circuits, PWM servo amplifier, PWM speed control and energy recovering brake, start and run motor control, automatic fan speed controller, efficient switching controller, closed loop motor speed control, servo system controller, switched mode motor speed controller, tackless motor speed controller, constant speed motor driver, DC motor drive with fixed speed control, bridge type AC servo amplifier, speed controlled reversible DC motor drive, PWM motor controller, stepping motor drive, high efficiency motor speed controller. This is PWM servo amplifier, PWM speed control, and energy recovering brake. Oh, that's cool. Start and run motor circuit, automatic fan speed controller, efficient switching controller, servo system controller, switch mode motor speed controller, closed loop motor speed control, tackless motor speed controller. This circuit is particularly applicable to digitally controlled systems in robotic and XY positioning applications. By functioning from the 5-volt logic supply, it eliminates additional motor drive supplies. The tackless feedback saves additional space and cost. The circuit senses the motor's back EMF to determine its speed. Oh, there you go. Constant speed motor driver, DC motor drive with fixed speed control, bridge type AC servo amplifier, speed controlled reversible DC motor drive, pulse width modulated motor controller, stepping motor drive, high efficiency motor speed controller. Multiplexers. 2-level multiplexer, 1 of 15 cascaded video mux, low cost 4-channel multiplexer, demultiplexer, 1 of 8 channel transmission system, 3-channel multiplexer with sample and hold, analog multiplexer with buffered input and output. 2-level multiplexer. 2-level multiplexer, 1 of 15 cascaded video mux, low cost 4-channel multiplexer, demultiplexer, 1 of 8 channel transmission systems, 3-channel multiplexers with sample and hold, analog multiplexer with buffered input and output, analog multiplexer with buffered input and output continued, Noise reduction circuits. Dolby BC noise reduction system. Dolby B noise reduction circuit in encode mode. Dolby B noise reduction circuit in decode code. I think it means decode mode, doesn't it? Dolby BC noise reduction system. Dolby B noise reduction circuit in encode mode. And Dolby B noise reduction circuit in decode mode. Notch filters. Twin T notch filter and a high Q notch filter. This is the Twin T notch filter. And this is the high Q notch filter. It's called a notch filter because it carves out a notch in the frequency. Operational amplifiers. Okay, we've got a couple of different operational amplifiers there. Optically coupled circuits. High voltage AC switcher, solid state zero voltage switches, ZVS, triggering SCR series, normally closed half wave ZVS contact circuit, normally open and normally closed DC solid state relays, indicator lamp driver, ambient light ignoring optical sensor, optical CMOS coupler, line current detector, line operated power outage light, optical TTL coupler, zero voltage switching solid state relay with anti-parallel SCR output, DC latching relay, AC relay, photodiode source follower, high voltage AC switcher. Got a lot of text. Solid state zero voltage switching ZVS circuits, triggering SCR series, normally closed half wave ZVS contact circuit, normally open and normally closed DC solid state relays, indicator lamp driver, ambient light ignoring optical sensor, optical CMOS coupler, line current detector, line operated power outage light, optical TTL coupler, zero voltage switching solid state relay with anti-parallel SCR output, DC latching relay, AC relay. Oh, look at that. That's fascinating. This has been torn and sticky taped back together. Oh, wow. So this must have been a second-hand book that I purchased because it's been torn and it's been fixed. Isn't that cool? I wonder if there was any notes in the margins. No. A common method of... what are we talking about here? Photodiode source follower. A common method of transforming the output current of a photodiode into a voltage signal paralleling the photodiode with a high-value load resistor produces a nonlinear response. Yeah, all right. Oscillators. Discrete sequence oscillator, fixed frequency variable duty cycle oscillator, RLC oscillator, HC-based oscillators, programmable frequency sine wave oscillator, variable Wien bridge oscillator, wide range oscillator, HCV HCT-based oscillator, 50% duty cycle oscillator, high frequency oscillator, last cycle completing gated oscillator, audio oscillator, low frequency oscillator, quadrature oscillator, Wien bridge oscillator, CMOS oscillator, XOR gate oscillator, SCR relaxation oscillator, CMOS oscillator, code practice oscillator, precision voltage controlled oscillator, 5-volt oscillator, low voltage Wien bridge oscillator. Discrete sequence oscillator. Discrete sequence oscillator. fixed frequency variable duty cycle oscillator, RLC oscillator, HC based oscillators, programmable frequency sine wave oscillator, variable Weill bridge oscillator, wide range oscillator, HCU HCT based oscillator, 50% duty cycle oscillator, high frequency oscillator, last cycle completing gated oscillator, audio oscillator, low frequency oscillator, quadrature oscillator, Weill bridge oscillator, CMOS oscillator, XOR gate oscillator, SCR relaxation oscillator, CMOS oscillator, code practice oscillator, precision voltage control oscillator, 5-volt oscillator, low voltage Weill bridge oscillator. Oscilloscope circuits, scope extender, 8-channel voltage display, oscilloscope calibrator, scope sensitivity amplifier, add-on scope multiplexer, oscilloscope preamplifier, oscilloscope counter preamplifier, oscilloscope triggered sweep, CRO doubler. Scope extender. The adapter allows for 4 inputs to be displayed simultaneously on a single trace scope. Interesting. 8-channel voltage display, oscilloscope calibrator, scope sensitivity amplifier, add-on scope multiplexer, oscilloscope preamplifier, oscilloscope counter preamplifier, oscilloscope triggered sweep, CRO doubler. Phase detectors, phase selector, phase detector, synchronous rectifier, balanced modulator, phase sequence detector, and phase detector. So the phase selector, phase detector, synchronous rectifier, balanced modulator. Gee, that's a mouthful. Phase sequence detector, phase detector. Photography related circuits. Slideshow timer, camera alarm trigger, dark room enlarger timer, flash meter, slave photographic xenon flash trigger, slide timer, electronic photo flash. Slideshow timer, camera alarm trigger, dark room enlarger timer, flash meter, slave photographic xenon flash trigger, slide timer, electronic photo flash. Power amplifiers, 50-watt audio power amplifier, output stage power booster, portable amplifier, Class D power amplifier, audio power amplifier, 6-watt power amplifier with preamp, hybrid power amplifier, 20-watt audio amplifier. So 50-watt audio power amplifier, output stage power booster, portable amplifier, Class D power amplifier, audio power amplifier, 6-watt audio amplifier with preamp, hybrid power amplifier, 20-watt audio amplifier. Fixed power supplies. Gee, there's a lot of these. Switching power supply, low cost, low dropout linear regulator, voltage doubler, isolated feedback power supply, handheld transceiver DC adapter, low dropout 5-volt regulator, dual tracking regulator, plus 15-volt 1 amp regulated power supply, minus 15-volt 1 amp regulated power supply. What did I say then? I meant to say minus 15 volts, 1 amp regulated power supply. 12-volt DC, battery operated, 120-volt AC power source. Simple power supply, general purpose power supply, low power inverter, 3 rail power supply, programmable power supply, triac controlled voltage doubler, high stability 10 volt regulator, voltage controlled current source with grounded source and load, charge pool power supply, bilateral current source, power converter, positive regulator with PMP boost, low forward drop rectifier circuit, safe constant current source, low cost 3 amp switching regulator, 50 watt offline switching power supply, efficient negative voltage regulator, 5 volt to isolated 5 volt at 20 milliamps converter, positive regulator with NPN and PMP boost, high current inductorless switching regulator, slow turn on 15 volt regulator, AC voltage regulator, uninterruptible plus 5 volt supply. So take a break. Alright, on we go. So this is fixed power supplies we're looking at the moment. Switching power supply, low cost, low dropout linear regulator, voltage doubler, isolated feedback power supply, handheld transceiver DC adapter, low dropout 5 volt regulator, dual tracking regulator, plus 15 volt 1 amp regulated power supply, plus that's continued, then minus 15 volt 1 amp regulated power supply, 12 volt DC battery operated 120 VAC power source, simple power supply, general purpose power supply, low power inverter, 3 rail power supply, programmable power supply, triac controlled voltage doubler, high stability 10 volt regulator, voltage controlled current source with grounded source and load, charge pool power supply, bilateral current source, power converter, positive regulator with PMP boost, low forward drop rectifier circuit, safe constant current source, low cost 3 amp switching regulator, 50 watt offline switching power supply, efficient negative voltage regulator, 5 volt to isolated 5 volt at 20 milliamp converter, positive regulator with NPN and PMP boost, high current inductorless switching regulator, slow turn on 15 volt regulator, AC voltage regulator, uninterruptible plus 5 volt supply, high voltage power supplies, arc jet power supply and starting circuit, pre-regulated high voltage supply, high voltage bucking regulator, high voltage DC generator, battery powered high voltage generator, opto isolated high voltage driver, simple high voltage supply, high voltage inverter, high voltage regulator, capacitor discharge high voltage generator, remotely adjustable solid state high voltage supply, arc jet power supply and starting circuit, pre-regulated high voltage supply, high voltage bucking regulator, high voltage DC generator, battery powered high voltage generator, opto isolated high voltage driver, simple high voltage supply, high voltage inverter, high voltage regulator, capacitor discharge high voltage generator, remotely adjustable solid state high voltage supply. Now we're up to variable power supplies. 100 kilohertz multiple output switching power supply, 3 to 30 volt universal power supply module, regulator / current source, low power switching regulator, variable voltage regulator, tracking pre-regulator, adjustable 10 amp regulator, 100 kilohertz multiple output switching power supply, 3 to 30 volt universal power supply module, regulator / current source, low power switching regulator, variable voltage regulator, tracking regulator, that's a tracking pre-regulator, adjustable 10 amp regulator, power supply monitors, power supply balance indicator, single supply fault monitor, power supply balance indicator, single supply fault monitor. Probes, digital logic probe, low input capacitance buffer, RF probe, CMOS universal logic probe, 4 to 220 volt test probe, battery powered ground noise probe, FET probe, pH probe and detector, stabilized low input capacitance buffer, RF probe, digital logic probe, low input capacitance buffer, RF probe, CMOS universal logic probe, 4 to 220 volt test probe, battery powered ground noise probe, FET probe, pH probe and detector, stabilized low input capacitance buffer, RF probe. Programmable amplifiers, inverting programmable gain amplifier, non-inverting programmable gain amplifier, wide range digitally controlled variable gain amplifier, digitally programmable precision amplifier, programmable gain differential input amplifier, programmable amplifier. We're inverting programmable gain amplifier, non-inverting programmable gain amplifier, wide range digitally controlled variable gain amplifier, digitally programmable precision amplifier, programmable gain differential input amplifier, programmable amplifier. Protection circuits, electric crowbars, AC power line connections monitor, line voltage monitor, power failure alarm, AC circuit breaker, fast over voltage protector, electric crowbars, AC power line connections monitor, line voltage monitor, power failure alarm, AC circuit breaker, fast over voltage protector. Proximity sensors, capacitive sensor alarm, UHF movement detector, proximity switch, SCR proximity alarm, and proximity sensor. Capacitive sensor alarm, UHF movement detector, proximity switch, SCR proximity alarm, proximity sensor. Ramp generators, logic pulsar, 300 volt pulse generator, very low duty cycle pulse generator, wide ranging pulsar, CMOS short pulse generator, voltage controller / pulse width generator. Logic pulsar, 300 volt pulse generator, very low duty cycle pulse generator. Wide range pulsar, CMOS short pulse generator, voltage controller / pulse width generator. We're up to ramp generators. Accurate ramp generator, integrator / ramp generator with initial condition reset. Accurate ramp generator, integrator / ramp generator with initial condition reset. Receivers, AM radio, FM tuner, FM MPX / SCA receiver, narrowband FM receiver, low-cost line receiver, FSK data receiver, simple ham band receiver, digital data line receiver, integrated AM receiver. AM radio, FM tuner, FM MPX SCA receiver, narrowband FM receiver, low-cost line receiver, FSK data receiver, simple ham band receiver, digital data line receiver, integrated AM receiver. Rectifier circuits, precision full wave rectifier, diodeless precision rectifier, a precision full wave rectifier, and a diodeless precision rectifier. Uses a CA3130 BIMOS op amp. Fair enough. Resistance/continuity meters. Cable tester, continuity tester, linear ohmmeter. So cable tester, continuity tester, linear ohmmeter. RF amplifiers. 1296 megahertz solid state power amplifier, 10 decibel gain amplifier, 2 to 30 megahertz amplifier, 450 megahertz common gate amplifier, RF wideband adjustable AGC amplifier, 1 megahertz meter driver amplifier, 5 watt 150 megahertz amplifier, UHS TV preamplifier, 60 watt 225 to 400 megahertz amplifier. This is the 1296 megahertz solid state power amplifier, 10 decibel gain amplifier, 2 to 30 megahertz amplifier, 450 megahertz common gate amplifier, RF wideband adjustable AGC amplifier, 1 megahertz meter driver amplifier, 5 watt 150 megahertz amplifier, UHF TV preamplifier, 60 watt 225 to 400 megahertz amplifier. Sample and hold circuits. Sample and hold, basic track and hold, sample and hold, high speed sample and hold, filtered sample and hold, sample and hold, sample and hold, track and hold, sample and hold, inverting sample and hold, sample and hold. Okay, so they're all sample and hold circuits. Sample and hold, basic track and hold, sample and hold. High speed sample and hold, filtered sample and hold, sample and hold, sample and hold. Track and hold, sample and hold, inverting sample and hold, sample and hold. Signal injectors. 2 signal injectors. This one uses a 555. Sine wave oscillators. Low distortion, thermally stabilized Wien bridge oscillator, single supply Wien bridge oscillator, super low distortion variable sine wave oscillator, audio generator. Low distortion, thermally stabilized Wien bridge oscillator, single supply Wien bridge oscillator, super low distortion variable sine wave oscillator, audio generator. This circuit produces a sinusoidal output of about 8 volts peak to peak, which can be varied down to 0 at about 500 Hz. The signal is generated by a phase shift oscillator. Sirens, warblers, and wailers. Electronic bagpipe, 2-tone siren, yelping siren, programmable frequency adjustable rate siren, the wailing siren, linear IC siren, super sound generator, hee-haw siren, electronic siren, 555 beep transformer, siren, 2-state siren, steam train with whistle. That's fun. Electronic bagpipe, 2-tone siren, yelping siren, programmable frequency adjustable rate siren, the wailing siren, linear IC siren, super sound generator, hee-haw siren. Yep, those are 555s. Electronic siren, 555 beep transformer, siren, 2-state siren, steam train with whistle. Solid state relay circuits. AC solid state relay. AC solid state relays. Solenoid drivers. Power consumption limiter. 12 volt latch. Hold current limiter. Power consumption limiter, 12-volt latch, hold current limiter. Sound effects generator, fuzz box, chug chug, electronic bird chirper, race car motor / crash. Sound effects generator, fuzz box, chug chug, electronic bird chirper, race car motor crash. Sound operated circuits, sound activated switch, voice operated switch, sound activated switch, voice operated switch. Splitters, wideband signal splitter, precision phase splitter. Wideband signal splitter, precision phase splitter. Square wave generators, square wave pulse extractor, nearly 50% duty cycle multivibrator, high current oscillator, quadrature output oscillator. Square wave pulse extractor, nearly 50% duty cycle multivibrator, high current oscillator, quadrature outputs oscillator. Staircase generators, micro A2240 staircase generators and a staircase generator. So there's two staircase generators. Strobe circuit, variable strobe light. Switching circuits, RF power switch, switch debouncer, SCR replacing latching switch, 1 MOS power FET analog switch, on-off inverters, RF power switch, switch debouncer, SCR replacing latching switch, 1 MOS power FET analog switch. On-off inverters. Each time the switch closes, the voltage on C1 causes inverter A to change state. Yeah, that's cool. Tachometer circuits. Low frequency tachometer. I'm actually going to put the that on-off inverter in the notes. That's page 594. On-off inverter. All right. Okay, tachometer circuits. Low frequency tachometer, and calibrated tachometer. There's a low frequency tachometer. Here's another tachometer. And a calibrated tachometer. Tape recorder circuits. Extended play circuit, sound activated switch, sound activated tape switch. Extended play circuit, sound activated switch, sound activated tape switch. Telephone related circuits. Oh gee, there's a lot of them. Of course, all of this sort of stuff is obsolete now. Single chip pulse / tone dialer. Telephone controlled nightlight. Hands-free telephone. Electronic telephone set with redial. Ringer relay. Tone dialing telephone. Telephone repeater. Speakerphone. Series telephone connection. Simple touch tone generator. Touchstone's got a trademark. Pulse dialing telephone, optically interface ring detector, parallel telephone connection, add-on telephone hold button, telephone handset encoder, dial pulse indicator, telephone sound level meter monitor, remote telephone ringer, telephone speech activity detector, duplex line amplifier, phone recorder, line activated solid state switch, cassette interface, ring detector, wireless telephone eavesdropper, telephone amplifier, telephone tap. Single chip pulse tone dialer. Pulse sword. You could use pulses or you could use tone. Is that why? Yep, this one's a tone dialer and this one's a pulse dialer. Telephone controlled nightlight. Hands-free telephone. Electronic telephone set with redial. Ringer relay. Tone dialing telephone. Telephone repeater. Speakerphone. Series telephone connection. Simple touch-tone generator. Pulse dialing telephone. Optically interface ring detector. Parallel telephone connection. Add-on telephone hold button. Telephone handset encoder. Dial pulse indicator. Telephone sound level meter monitor. Remote telephone ringer. Telephone speech activity detector. Duplex line amplifier. Phone recorder. Line activated solid state switch. Cassette interface. Ring detector. Wireless telephone eavesdropper. Oh dear me, that's naughty. Telephone amplifier. Telephone tap. Oh, it's as simple as that. They've just got a transformer there. Temperature controls. It says here, amplify or record a telephone call with the simple circuit shown. The 8 ohm secondary winding of a miniature transistor output transformer is connected in series with either of the telephone lines. The 1 kilo ohm primary winding can feed either a cassette recorder or an audio amplifier. Temperature controls. 0-point switching temperature control, servo sensed heater protector, temperature controller, proportional temperature controller, piezoelectric fan-based temperature controller, electronic heat sniffer. 0-point switching temperature control, servo sensed heater protector, temperature controller, proportional temperature controller, piezoelectric fan-based temperature controller, electronic heat sniffer. Temperature sensors. The sources of the following. Oh yeah, okay. This is temperature sensors. Thermocouple multiplex system. 0 to 63 degrees Celsius temperature sensor. Isolated temperature sensor. Thermocouple multiplex system. 0 to 63 degrees temperature sensor. Isolated temperature sensor. Temperature to time converters. 2 simple temperature to time converters. How do you convert a temperature to time? Both of these converters use CMOS inverters. Figure 105.1a shows a free-running circuit having both the pulse duration and pulse pause dependent on temperature. Oh, I see. So to time, it really means to frequency, I think. Fair enough. Tesla coils. Simple Tesla coil, Tesla coil. All right, there's a simple Tesla coil. And then is this perhaps a more complicated Tesla coil? Thermometer circuits. Differential thermometer, temperature reporting digital thermometer, electronic thermometer, temperature measuring add-on for DMM, digital multimeter, digital voltmeter, implantable, ingestible electronic thermometer. Wow. Simple linear thermometer, thermometer adapter. Differential thermometer. Temperature reporting digital thermometer. Electronic thermometer. Temperature measuring add-on for digital multimeter, digital voltmeter. Implantable, ingestible electronic thermometer. This oscillator circuit includes a quartz crystal that has a nominal resonant frequency of 262,144 Hz and is cut in the orientation that gives a larger linear coefficient of frequency variations with the temperature. In this type of circuit, the oscillation frequency is controlled primarily by the crystal, as long as the gain bandwidth product is at least 4 times the frequency. In this case, the chosen component values yield a gain bandwidth product of 1 MHz. Indicator L1 can be made very small, 100 to 200 turns, with a diameter of 0.18 inches or about 4.8 millimeters, and a length of 0.5 inches, which is about 12 millimeters. Although the figure shows 2 transistors in parallel, 1 could be used to reduce power consumption, or 3 could be used to boost the output. The general oscillator circuit can be used to measure temperatures from -10 to 140 degrees Celsius. A unit made for use in the human body from about 30 to 40 degrees Celsius operates at 262,144 plus or minus 50 Hz with a frequency stability of 0.1 Hz and a temperature coefficient of 9 Hz per degree Celsius. Simple linear thermometer, thermometer adapter, tilt meter, digitizer, time delay circuits, electronic time delay, timing threshold and load driver, simple time delay, electronic time delay, timing threshold and load driver, simple time delay. Timers, sequential timer, CMOS precision programmable laboratory timer, long time timer, one-shot timer, 3-minute timer, sequential timer, CMOS precision programmable laboratory timer, long time timer, one-shot timer, 3-minute timer, tone control circuits, IC preamplifier / tone control, 10-band octave equalizer, 3-band active tone control, Weiand bridge filters, rumble scratch filter, IC preamplifier / tone control, 10-band octave equalizer, 3-band active tone control, Weiand bridge filter, rumble scratch filter. Touch switch circuits, negative triggered touch circuit, positive triggered touch circuit, digital touch on/off switch, 2-terminal touch switch, touch on/off electronic switch, line hum touch switch, touch switch. Negative triggered touch circuit, positive triggered touch circuit, digital touch on/off switch, 2-terminal touch switch, touch on/off electronic switch, line hum touch switch, touch switch, touch switch, touch switch. There we go. Tracking circuits, track and hold, positive and negative voltage reference tracker, signal track and hold. Track and hold, positive and negative voltage reference tracker, and signal track and hold. I'm going to take a quick break. All right, this is transducer amplifiers. Differential to single-ended voltage amplifier, equalized preamp for magnetic phono cartridges, photodiode amplifier, tape playback amplifier, NAB record preamplifier, magnetic phono preamplifier, 2-pole NAB type preamp, flat response tape amplifier. Differential to single-ended voltage amplifier, equalized preamp for magnetic phonograph cartridges, photodiode amplifier, tape playback amplifier, NAB record preamplifier, or NAB record. I'm not sure what NAB means. Let's see if I can figure it out. So NAB stands for North American Broadcasters, and it's another standards body who made a standard similar to that RIAA one that we saw earlier. So there you go. Two-pole NAB type preamp, magnetic phono preamplifier, flat response tape amplifier. Transmitters. I don't know what 80M amateur radio transmitter, TV transmitter, FM voice transmitter, 1 watt continuous wave transmitter, low cost half duplex information transmission link, FM snooper, VHF tone transmitter, low frequency transmitter, wireless FM microphone, beacon transmitter, 40 CW transmitter, VHF modulator, wireless FM microphone, 902 MHz CW transmitter, 1 transistor FM transmitter, FM multiplex transmitter, QRP CW transceiver, wireless FM microphone. ADM, amateur radio transmitter. I don't know what it means by ADM. Don't know. TV transmitter. Oh, that's fun. FM voice transmitter. 1 watt continuous wave transmitter. Low cost half duplex information transmission link. FM snooper. VHF tone transmitter. Low frequency transmitter. Wireless FM microphone. Beacon transmitter. 40M CW transceiver. VHF modulator. Wireless FM microphone. 902 MHz continuous wave transmitter. A 1 transistor FM transmitter. FM multiplex transmitter. Oh, that's interesting. QRP CW transceiver. Wireless FM microphone. Tremolo circuits. We've seen these before. It's a musical instrument of sorts. So tremolo, electronic tremolo, and tremolo. Okay, so there's a whole different way, 4 different ways of doing it. Cool. Ultrasonics. Ranging system, ultrasonics receiver, ultrasonic pest repeller, 20 kilohertz arc welding inverter, ultrasonic transceiver, sonar transducer / switch, 120 kilohertz 500 watt induction heater, ultrasonic transceiver, ultrasonic receiver, ultrasonic pulse pest controller, ultrasonic pest controller. The idea is that you make a high-pitched tone that the pests can hear and it keeps them away. But it's, I don't know how scientific it is. It might be more of hope than effect. Ranging system. Ultrasonic receiver. Ultrasonic pest repeller. 20 kilohertz arc welding inverter. Ultrasonic transceiver. Sonar transducer / switch. 120 kilohertz 500 watt induction heater, ultrasonic transceiver, ultrasonic receiver, ultrasonic pulsed pest controller, ultrasonic pest controller. This circuit consists of 2 basic parts: an oscillator tuned to 40 kilohertz and a voltage doubler with pulse generator. The pulses are about 10 milliseconds long and occur 2 to 3 per second to reduce battery drain and increase the annoyance factor for a cat, dog, hedgehog, etc. The voltage doubling action increases the available output power for any given battery voltage. Video amplifiers. RGB video amplifier, video line driving amplifier, summing amplifier / clamping circuit, DC gain controlled video amplifier, 75 ohm video pulse amplifier, video gain block, low distortion video buffer. RGB video amplifier. Video line driving amplifier, summing amplifier / clamping circuit, DC gain controlled video amplifier, 75 ohm video pulse amplifier, video gain block, low distortion video buffer, video circuits, RGB composite converter, single supply wide range sync separator, chroma demodulator with RGB matrix, composite video signal text adder, PAL / NTSC decoder with RGB inputs, wireless video camera link, video switch with very high off isolation, video palette, picture fixer / inverter, video DC restorer, color TV crosshatch generator, general purpose video switch, video signal clamp, automatic video switch, high performance video switch. RGB composite converter, single supply wide range sync separator, chroma demodulator with RGB matrix, composite video signal text adder, PAL / NTSC decoder with RGB inputs, wireless video camera link, that's interesting, video switch with very high off isolation, video palette, sure what that does, picture fixer / inverter, video DC restorer, color video amplifier, color TV crosshatch generator, general purpose video switch, video signal clamp, automatic video switch, high performance video switch, voice circuits, AC line voltage announcer, AC line voltage announcer, dialed phone number vocalizer, computer speech synthesizer, allophone generator, electronic voice substitute. AC line voltage announcer, dialed phone number vocalizer, computer speech synthesizer. This text-to-speech converter is built around the SPO256AL2 speech processor and the CT6256AL2 text-to-speech converter chips manufactured by General Instruments. The circuit is set up to receive standard ASCII code from virtually any microcomputer or dumb terminal that is equipped with an RS-232 port, such as a serial printer or modem port. If a microcomputer is used, the synthesizer can be activated from a terminal emulator of any communications program or from any programming language such as BASIC. Allophone generator. Electronic voice substitute. Voltage controlled oscillators. balanced TMOS VCO, waveform generator / stable VCO, variable capacitance diode, sparked VCO, logarithmic sweep VCO, supply voltage splitter, 3 to 5 volt regulated output converter, VCO, simple VCO, balanced TMOS VCO, waveform generator / stable VCO, variable capacitance diode sparked VCO, logarithmic sweep VCO, supply voltage splitter, 3 to 5 volt regulated output converter, VCO, simple VCO. Voltage converters, unipolar to dual supply converter, efficient supply splitter, high efficiency flyback voltage converter, 3 to 25 volt DC-DC converter, regulator 15 volt V out 6 volt driven converter, 1.5 watt offline converter, dual output plus or minus 12 or plus or minus 15 volt DC-DC converter, 12 to 6 volt converter, self-oscillating flyback converter, unipolar to dual supply converter, efficient supply splitter, high efficiency flyback voltage converter, 3 to 25 volt DC-DC converter, regulated 15 V out 6 volt driven converter, 1.5 watt offline converter, dual output plus or minus 12 or plus or minus 15 volt DC-DC converter, 12 to 16 volt converter, self-oscillating flyback switching converter, voltage to frequency converters, 1 Hz to 30 MHz voltage to frequency converter, differential input voltage to frequency converter, low cost voltage to frequency converter, wide range voltage to frequency converter, 5 kHz to 2 MHz voltage to frequency converter, preserved input voltage to frequency converter, 1 Hz to 10 MHz voltage to frequency converter, voltage to frequency converter, 1 Hz to 1.25 MHz voltage to frequency converter, accurate voltage to frequency converter, voltage to frequency converter. Alright, well there's a lot of these. 1 Hz to 30 MHz voltage to frequency converter, differential input voltage to frequency converter, low cost voltage to frequency converter, wide range voltage to frequency converter, wide range voltage to frequency converter, 5 kHz to 2 MHz voltage to frequency converter, preserved input voltage to frequency converter, 1 Hz to 10 MHz voltage to frequency converter, voltage to frequency converter, 1 Hz to 1.25 MHz voltage to frequency converter, accurate voltage to frequency converter, voltage to frequency converter. Voltage meters / monitors / indicators. Voltage level indicator, 4.5 digit digital voltmeter, full scale 4 decade 3.5 digit DVM. Over under voltage monitor, high input resistance DC voltmeter, voltage freezer, multiplexed common cathode LED display ADC, AC voltmeter, FET voltmeter, sensitive RF voltmeter, voltage monitor, audio millivoltmeter, high input resistance voltmeter, frequency counter, audio millivoltmeter, low voltage indicator, FET voltmeter, simplified voltage level sensor, peak program detector, wide range AC voltmeter, visible voltage indicator. Voltage level indicator, 4.5 digit DVM, full scale 4 decades 3.5 digit DVM, over under voltage monitor, high input resistance DC voltmeter, voltage freezer, multiplexed common cathode LED display ADC, AC voltmeter, FET voltmeter, sensitive RF voltmeter, voltage monitor, audio millivoltmeter, high input resistance voltmeter, frequency counter, audio millivoltmeter, low voltage indicator, FET voltmeter, simplified voltage level sensor, peak program detector. This circuit will allow multimeter to display the positive or negative peaks of an incoming signal. Wide range AC voltmeter, visible voltage indicator, voltage references, bipolar reference source, expanded scale analog meter, digitally controlled voltage reference, bipolar reference source, expanded scale analog meter, digitally controlled voltage reference, window detectors, comparators, discriminators, digital frequency window, window detector, window detector, window detector, window detector, simple window detector, multiple aperture window detector. Here is a digital frequency window, window detector, window detector, window detector, window detector, simple window detector, multiple aperture window discriminator. And we're up to the index. Cool. So, this is the sources. Yeah, right. So this will tell you where the circuits came from. Various publications. And then after the sources, there's there's another index, I think. Yeah, here's the index. And it'll tell you anything in the 3 volumes that we've seen, this one and the 2 volumes that came before it. So it's a cumulative index. It's a ripper. And what have they got in the very back of the book after the index? Have they got anything else? Other bestsellers of related interest. We've got the Benchtop Electronics Reference Manual, 2nd edition. Basic Electronics Theory, 3rd edition. Computer Technician's Handbook, 3rd edition. Electronics Equations Handbook. International Encyclopedia of Integrated Circuits. And Troubleshooting and Repairing Electronic Circuits. Cool. And then we've got Electronic Conversions, Symbols and Formulas. And Troubleshooting and Repairing the New Personal Computers. This is a treasury of time and money-saving tips and techniques that shows personal computer owners and service technicians how to troubleshoot and repair today's new 8 and 16-bit computers, including IBM PC, XT, AT, and compatibles, the Macintosh, the Amiga and Commodores, and other popular brands. Margolis examines the symptoms, describes the problem, and indicates which chips or circuits are most likely to be the source of the trouble. 416 pages, 351 illustrations. Book number 2809, 1995 paperback, $29.95 hardcover. Cool. All right. Well, we got our way through the book. We've seen inside it. I'll throw over the farewell cam. We'll wrap up. And that's a wrap. So we made it through the book. That was the volume 3. We learned a couple of things along the way. I made some notes about circuits that I'd like to make, and I'll come back to this. I'll put these notes in the show notes. On page 245, there was the electronic dice. I think it'd be fun to make those. Then there was the simple adder circuit in 327 on page 327. And I thought it'd be fun to make a couple of those and see if we could get them to add multiple digits with, presumably they have a carry bit. And then on page 337, we got the electrostatic detector. And that sounded similar to the MOSFET tester that I was looking at recently, so that's why I made a note about that. I'll have a look at it. And then page 594 are the on-off inverters. So just for circuits of interest for the show notes, we had to look up a few things while we were going through the notes. We learned about the RIAA standards for vinyl records and the NAB standards for cassette. Anyway, I'll put some notes about that in the show notes as well. So that concludes this video. I hope you enjoyed this video. Thanks very much for watching, and please remember to click like and subscribe.